All right, so we've established that first equilibrium, and we have just done the straight ice table, the same kind of problems that we had for the first exam. We didn't do anything fancier than that. But this bottom line here are my actual equilibrium concentrations. They are in terms of molarity. The combined molarity term, and when I say combined, I mean the moles with the liters, is less useful when we're thinking about changing volume, because now I need to know what my new molarity is, so I need to start all the way over with moles. Now, when I moved from my initial concentration to my equilibrium concentrations, I didn't do a whole lot with the concentration of the reactants. So I can go ahead and assume that I'm also not going to do very much with the moles. And that for my new initial, my new system, I done screwed it up. But at equilibrium, for my new system, I'm going to start with about the same amount of moles for both of these guys. Now, in terms of AB, I didn't have any moles for that first initial that I had. I did end up with some moles when I got to equilibrium, though. So now I have to figure out how many moles that is. Okay, I'm going to scroll down just a little bit, and I'm going to say, okay, I know the concentration of AB at equilibrium before I messed anything up is 2 times 10 to the minus 7. Now, that's not a made-up number. That's what we got in the last video. That's in terms of moles per liter. I can say that I don't really know how many moles, but I do know that I was in a volume of 0.1 liters because that's what was mixed. My reactants were delivered in 0.1 liters, which means that my products would have to be formed in the same volume. So I can do that math, and I can get a new value for my moles. That's what my X is equal, and that's going to be, whoops, not concentration. That's going to be moles of AB. So I'm going to go back up here, and I'm going to put that in here. So now I have the moles of everything that are in that mixture, because it's this mixture here that we're going to change the volume on and see how the equilibrium shifts. When I change that volume, I change from 0.1 liters or 100 mils to 0.2 liters or 200 mils. So now I can get my new molarities, which would be my new initial. Okay, all of those are in molarities. Okay, take 0.01, divide it by 0.2, you get 0.05. Now, if the question asked me to, I could actually figure out new equilibrium concentrations. Now, that's not necessary for this question, but I could if I wanted. Okay, we have all the information we need to do that, because at this point, we would set up the ice table in a very similar manner to what we did before. What we are going to do now, though, is figure out Q, because what we couldn't do in this ice table necessarily right now is figure out the change. We don't know which one's positive X, and we don't know which one's negative X. So for now, we're going to figure out Q. We know that we have 1 times 10 to the minus 7 molar AB, which is our only product, and we have 0.5 molar A and CB, both of our reactants. So I can figure out Q. It's set up just like K, and I get a value of 4 times 10 to the minus 5, which happens to be bigger than 2 times 10 to the minus 5. So my Q is greater than my K, which means if I think in terms of products over reactants, there's too many of products right now, too many of these, so I'm probably going to consume them and shift towards reactants. Now, this question just simply wants to know which way our reaction shifts, and so we answered that question already. If we did have to go back and figure out the actual equilibrium concentrations, we can take this qualitative statement and say, okay, there's too many products. Too many means I'm going to have to consume the products. When I consume the products, that's minus X. If I'm going to move towards reactants, those guys have to be plus X. So we can use this Q versus K reasoning to figure out the change for our second ice table, because we had an ice table, screwed up the equilibrium. Now we have to have a new ice table. And so you could go through if you wanted, and you could set up your K in the exact same manner that we did in the other video, and you could solve for X.